Factors that determine damage. The severity of the environmental impact often depends on where the data center is built. Power grid mix. Facilities located in states like Kansas and California, which have higher proportions of wind and solar energy, produce significantly fewer emissions than those in fossil fuel heavy regions like Northern Virginia. Cooling technology. Some operators are moving towards liquid cooling or closed loop systems to reduce water evaporation through these technologies, often required more energy to operate. Sustainable siting. Researchers suggest that building in the wind belt, Texas, Nebraska, or South Dakota, is more sustainable because these areas offer an abundant land and potential for renewable energy. Here in Arizona, Mason Carroll, a reporter for Arizona's Family, reported that the community in Page, Arizona and surrounding communities are concerned about a $10 billion data center. The people in Page, Arizona are fighting back against the land being sold for this data center. The land recently sold by the city also sits adjacent to Horseshoe Bend. The locals are worried about the water usage and in the area where it is already scarce. I personally know that several lakes feed into the public drinking water here in Arizona and surrounding states. Roosevelt Lake, Bartlett Lake, and other surrounding lakes supply fresh water to these cities and our communities. Arizona cannot afford to lose more water, especially given we are always in a drought level. What happens to the water data centers use after they are done with it? Well, I researched that as well. Mind you, I'm sticking strictly with AI mode, the very thing that they are creating and putting across our country, probably the world. Answer. When the data center is finished with its water, it typically follows one of two paths, depending on the cooling technology used. It is either evaporated into the atmosphere or discharged as wastewater. The water that remains in the system, which cannot be reused indefinitely because it becomes concentrated with minerals and salts, is known as blowdown. Municipal sewage. Most data centers discharge this remaining 20 to 50% into local municipal wastewater facilities. On-site treatments. Some modern facilities treat this water on-site before releasing it or reuse it for secondary purposes like irrigation or flushing toilets. Direct discharge. In some cases, water is discharged directly into local bodies of water like rivers or lakes through its strictly regulated, though it's strictly regulated to prevent thermal pollution, heat from harming the ecosystem. I then asked what this discharge water will do to the environment, ecosystems, our farmers and ranchers, and is this discharge water safe for human consumption? Human consumption. Even though the water may look clean, it can contain things that make it unsafe. Chemical additives. Cooling water often has anti-corrosion chemicals, biocides to kill bacteria and algae, scale inhibitors. These help protect equipment but are not meant for drinking. Mind you, this is all fresh water they're using. They're not using salt water, which that would kill that ecosystem and the animals that live there as well. Then I asked, what will these wastewaters do to the environment and ecosystems? Wastewater from data centers can affect the environment and ecosystems, but the level of impact depends on how it's managed, treated, and regulated. Thermal pollution, warm water. One of the biggest concerns is heat. Data centers release water that it has absorbed heat from cooling system. Why does this matter? If warm water is discharged into rivers, lakes, wetlands, it can raise water temperatures, reduce oxygen levels, stress or kill fish and aquatic life. Many species are sensitive to temperature. Even a few degrees of change can disrupt spawning cycles, migration patterns, food chains. This is especially concerning in already warm or drought-prone regions. Chemical contaminations. Cooling water often contains treatment chemicals to prevent corrosion, bacteria, and mineral buildup. These may include biocides, anti-scaling agents, corrosion inhibitors. If not properly treated, they can harm aquatic organisms, disrupt microorganisms in soil and water, affect pollinators and wildlife indirectly. Environmental standards set by the U.S. Environmental Protection Agency requires treatment before discharge, but monitoring and enforcement can vary. Heavy metals and residues. Water moving through pipes and systems can pick up trace metals like copper, zinc, iron, and over time these can accumulate in sediments, enter our food chain, affect fish, amphibians, and birds. This process is called bioaccumulation and can affect predators higher up in the ecosystem. Soil and plant impacts. If discharged water is reused for irrigation, high salt or chemical levels can damage the soil. Plants may struggle or absorb contaminants. Long-term soil fertility can decline. This is especially important in agriculture areas.